Audio check 1, 2, 3. Okay, good morning, gentlemen. Out of respect for everybody's time, I'm going to start promptly in about 1 more minute. We'll just wait about 1 more minute for everybody to join. This session is being recorded and will be placed in the recorded presentations link on my TCC Blackboard for later review. Since this is a synchronous session, some people may not join and may be able to review it asynchronously. So we're recording all sessions just like we'll record the lab walkthrough on the live lab sessions. Okay, stand by 1 and we'll start in just a second. Okay, audio's back on. Echo, good, audio's working. Okay, good morning. Welcome to the TCC initial class for Cisco. Here's what we're going to do today. I'm going to show you guys the My TCC Blackboard pages that correspond to this course. We'll look at what our education is called, the ICR, Instructor Course Requirements, and what us normal people would call a syllabus. And then we'll look at the Cisco Network and Academy website as well. You guys have been granted access to the Cisco Network and Academy site, and some of you have already logged in. This is good. I'm going to briefly go through some highlights of Chapter 1, but I'm going to spend most of my time today on Chapter 2. And then Wednesday at 9 a.m., we're going to have our first in-person lab session at the South Campus Business Building, SBUS 1125. Okay, so first of all, I'm going to cover my TCC Blackboard. So let me stop sharing this. And I want to share, let's see, I need to share the application window for this one, I think. Okay, so what you guys are seeing is the student view of my TCC Blackboard. This is pretty much the same as you will see when you log in your TCC myself. This is what you just logged into now. You clicked on the bottom link that said Blackboard Collaborate Ultra. You get into the sync session, the Zoom-like sync session we're using for our synchronous courses, and they'll be recorded and be available later for later review. Okay, so every time you log into Blackboard, initially you see this announcement screen. So here, here I'm stating that the lecture classes will be every Monday at 9 a.m. And they'll be recorded for later review. Wednesdays will be our in-person lab sessions in SBUS 1125 in the Cisco Laboratory at South Campus. If you do not wish to go to any or a Wednesday lab session in person, you have the option and the alternative of completing the lab assignments. Instead of the actual real equipment we have on the Cisco lab, you can use the Cisco Packet Tracer software. This is a computer program lab simulation software that Cisco makes free of charge for, actually free of charge for World Plus Dog, everybody in the world. Even if you're not paying the $64 an hour to go to a community college and take the Cisco class, anybody in the world can go to netacad.com and sign up for a free course, Packet Tracer 101, and get this program for free. Hang loose 1 second. We've got a, okay, I'm going to wait a second on the attendance here. We got some people joining. Okay, so let's look at the different parts of my TCC Blackboard here. So when you log on initially, you'll see this. Okay, I've clicked on the class syllabus, and I'm going to click on this link, and this is going to bring up the instructor course requirements, instructor class requirements, which you would probably call a syllabus anywhere else in the world. So I'm a full-time instructor here of information technology and computer science. I've been teaching the Cisco courses for over 20 years now. And I teach this fundamentals course on Mondays and Wednesdays. And then I teach a more advanced course on Tuesdays and Thursdays. So since the classes start at 9 a.m. and they're scheduled to start at 11:30, although I usually talk fast, but the students finish the labs first, I blocked out that time during we have classroom and laboratory hours. So my office hours start at 8 a.m. before the class, and they end at 3 p.m. in the afternoon. We used to wait around in our offices, but since we're under lockdown now, no, we can't do that anymore. We got to do everything by email. So I check my email several times a day. You can check on this. Okay, the books in this course are you get a free ebook on the Cisco Networking Academy, which we're going to look at in just a minute. And then here's some stuff here that the educationists, I'm not going to give them the honor of calling them educators. I'm an educator. The educationists are the administrators that run this joint, and they have master's and doctorate degrees in education, but they couldn't teach an algebra course if you held a gun to their head. Okay, so there's some stuff that they made us put here. So no required print text. You get free online access to all what the librarians call non-print media. It's an ebook. It's an online ebook. You'll get forever access to this. If you don't log in every 180 days or so, you might have to change your password. Since this has been the Cisco Networking Academy is the world's single largest, most successful e-learning initiative. It's been around for over 20 years. Over 7 million students have passed through our doors. We have 12,000 academies worldwide. You get access to that at no charge. So this is a networking fundamentals course. Now let me explain for a little bit about Cisco has recently changed the objectives. Some of you guys are probably in here to get your CCNA certification, Cisco Certified Network Associate certification. Maybe some of you are in here just because this fulfills the network fundamentals requirement. You can take this course or you can take the ITN W1425 course, and that fulfills the networking fundamentals requirement of most of the computer science and information technology courses. So this is a fundamentals course. No previous knowledge is assumed. Third or fourth grade math skills would come in handy. Don't worry, you've heard of the dreaded and feared subnetting and binary. It's really no more than third or fourth grade addition, multiplication, multiplication and division. It's not that difficult. So we're going to look at things for networking fundamentals, the technologies, what devices connect them together. We'll look at the network addressing scheme, IP addressing, which is kind of the same as area codes and telephone numbers in the telephone system. Kind of the same as street addresses and zip codes in the mail system. And we'll see how we can connect things together using those numbers. So there used to be 4 courses. This course was the first course, and there were 3 other courses. Cisco has recently revised their curriculum, and they've thrown out about 25% of the objectives. So now to get your CCNA, it's 25% easier because there's only 75% of the objectives that used to be in here. Now, here in education, we typically go at a pace which I will describe as glacial. We're very slow. We need years of preparation to change things up. So in the course catalog, you still see these 4 Cisco courses, this course and the 3 others beyond it. Okay, you guys that are actually in here to get your Cisco certification, when you come back in the spring, if you come back to my campus, well, I'll be teaching the 2 courses you need to take. The Cisco 2 course, Routing and Switching Essentials is what it used to be called. You don't need to take that. That's going to be this course. And if you take this first course, it's the baby Cisco course. So we're gradually merging over, we're melding over to a new system where the first course is going to be a baby Cisco course, a subset of this course. The second course will be this course. I have put it in this course number for the fall as a courtesy to South Campus students so that they can come back in the spring and go to my campus or any of the other campuses that teach the Cisco curriculum and just be able to take what we call Cisco 3 and Cisco 4, and you'll be completely prepared for the to go and take the CCNA test. Get that test. And nothing confusing about all that, is there? Okay, so we used to require you to come in person to all the lectures and all the labs. Well, we can't make you do that anymore because of the virus theater thing. So we're recording all the lecture sessions. You can come in person, or you can come and watch it later, or if you were confused during when you're listening to me right now, you can come back and you can review it later. Because but later in this afternoon, I'll have this recording posted to the recorded presentations. We'll see what that looks like in just a second. So the laboratories, you're going to get more benefit if you come to the physical laboratories on Wednesday and work on real actual equipment. Kind of like if I was going to teach you automotive repair or welding, would it be of more value for you to work on a real welding machine or work on a real car or to work on a computer lab simulation on software? However, if you don't want to come to any or all of the laboratory sessions on Wednesday, you have the option of not coming to them and using the remote lab option using the Cisco packet tracer software, which is free for you. So that's why I've had to cross out some of this stuff about, well, we don't grade on attendance. We're going to only be grading on 50% of your grade is going to be on the 10 chapter exams that we're going to use on the Cisco Networking Academy. And the other 50% of your grade will be on the other 6 or 7 labs in this particular one. Okay, so the online chapter assessments are on the Networking Academy, which we're going to look at in just a little bit. There's 11 chapters. I'm not going to use the chapter 1 test. That's not going to be required. So there's going to be exactly an even number of 10 labs. I'll add those 10 labs up and do the average, and that will be 50% of your grade. The laboratory assignments, you can do any combination of in-person or remote with packet tracer, and those will be added up and averaged, and that will be the other 50% of your grade. At this time, I'm not doing a skills assessment, which is a sort of another lab that used to count a lot more. The final examination will be averaged together with your 10 chapter exams that I require. That'll be 50% of your grade. And then the 7 or so labs that we have will be averaged together, and that'll be the other 50% of your grade. So here's this. Final grade. Laboratories. I do drop the lowest lab grade, so you can safely skip 1 lab and it won't hurt your grade. You won't get any extra credit if you do them all, but you can drop 1. The 11 chapter tests and the final exam, well, it's only going to be the 10 chapter test because I'm dropping chapter 1. Chapter 1 will not be required. I've got it turned on right now just so I can show you how you take a test, but it won't be required. If you take it, it won't affect your grade. There are some other things on the Academy like quizzes. Those are not required. You can take them if you want to, but they're not counted in your grade. Like the IRS, I do 5-4 rounding. So if your grade is 89.5, I will round that up to a 90 and you'll get an A. If your grade is 79.5, I will round that up and that'll be 80 and you'll get a B, and so forth. Okay, so this is the same thing that we saw in the announcements portion of my TCC Blackboard. We'll have our lecture classes at 9 a.m. every Monday. And on Wednesday, I will be happy to meet you in the SBUS 1125 Business Building at South Campus if you want to come in there and do labs on real actual equipment. If you don't want to come to any or all or any particular Wednesday lab session, you can complete it using the packet tracer software, and that'll be free on there. So here's our schedule. Today is the 19th of October, Monday, and we're going to cover chapters 1 and 2. I'm going to very briefly just skim over chapter 1. And I'm going to cover chapter 2 in depth because this is important information on how do we type in the commands to configure Cisco devices like routers and switches. And then Wednesday, we'll do our first lab 2.3.3.3. The week of Thanksgiving, we're closed the entire whole week. Right? This is not like grade school where you got to leave early in the afternoon of the Wednesday before Thanksgiving. We close the whole darn week. I think the public schools are doing that now too. So there will not be any classes on the week of Thanksgiving. Now, this is only an 8-week course. It's almost Halloween. We're starting now. So our final exams will sort of be the same period of time as most people that have taken the 16-week course, normal long semester course. Due to the virus theater stuff, instead of only being 1 day where you can come in person and take the final exam, you'll be able to take it remotely. And it's going to be on for like a whole week. So I'll turn the final exam on Wednesday, the 9th of December in the morning. It'll be on through the following Wednesday at 5 p.m. in the afternoon. And by the way, all the chapter exams and final exams are open book. So our final deadline for completing all work will be that Wednesday, December the 16th by 5 p.m. All work has to be turned in by that time because I've got a dean who was in the Marines for 30 years and he don't take no guff. And my grades have to be in by then or I'm in big trouble. Okay, so there's some more education and stuff in here, talking about how we had to change the teaching and learning adaptations because we're doing a lot of stuff through remote stuff and things of that nature. Okay, so I want to go now to click on the next link, which is my grades. Now this is Blackboard nonsense. We have to put in some big numbers. I always get a complaint from the end of the semester, oh, it had 33 points and I only got 25 points. You have to put bigger numbers in there. Don't worry, Blackboard is just, well, we're getting rid of Blackboard and we're going to Canvas, which is another learning management system, or LMS. Cisco Networking Academy is already on Canvas. However, they're going to Moodle. They're changing. So when you come back in the spring, we maybe have some different stuff here. So this is how you can see the stuff that's in my TCC Blackboard is going to be out of date until the last week of classes, because we're required to use Blackboard to calculate your final grade. So after the last week of class, during the last week of class, I'll transfer all your grades over for your 10 chapter exams and your final exam on the Cisco Network Academy side. And I'll add in a number here for your labs that you turned in. I'll just put a 1 in there as a check mark that you turned in the lab. But your labs are worth 50%, so I'll add a number there to make your labs. If you do all the labs or all the labs minus 1, you're going to get the full 50 points for that part of it. There is a course evaluation link, which you can click toward the end of the semester. We ask that you do that's like a customer satisfaction survey or a student satisfaction survey. It's totally anonymous. I can't see any of your complaints or even the good things you say about me. There is another student satisfaction survey on the Cisco Networking Academy, however, that's required before you take the final exam, because Cisco is very dead serious about keeping the statistics on the 10 million students that have gone through this course. Okay, course presentation materials. This is death by PowerPoint. So today, I'm going to, is this wiggling? Can we see this? Okay, good. I'm going to cover chapter 1, just a few highlights from chapter 1. I'm going to do this. Not very many slides. But I'm going to really get serious, and I'm going to use this alternate chapter 2 PowerPoint to cover. This is going to take most of the time today to go through the slides to talk about how we type in commands and configure routers and switches to have network addresses and ping them and things of that nature. When we come on Wednesday and do our labs, we're going to do this lab first. And I'm going to show this, and I'm going to show Packet Tracer on the screen for you guys today, just to see how it works, what it looks like. You guys that don't want to come in, you can see how Packet Tracer works. You guys that want to come in on Wednesday and actually do it, we'll get down and do our real equipment. And Wednesday, I will record, I will run through the entire lab. I'll do a walkthrough on the entire lab. On the real equipment we have in the building there, I'll record that and I'll post it as well to this. Okay, we have some chapter study guides that extra reading material just to help you evaluate how you're doing on the particular chapter. You can read this. These are Microsoft Word documents that you can read and kind of bone up on a chapter before you take the test or something of that nature. There is a district syllabus, an official syllabus of what this course covers. These are in the process of being revised because these are the old Cisco curriculum objectives that were changed about a year ago, and these will be eventually updated. But like I say, in education, we tend to do this stuff kind of slowly. Eventually, we will change our course numbering schemes to reflect the new objectives. In the meantime, we're sort of in a migration scheme as we go from the old numbers to the new numbers. Okay, on the recorded presentations page, as the semester progresses, I will post all these Monday lectures. I'm recording this in the entirety. I will post it here. It'll be here by later this afternoon. It's Blackboard. It takes an hour to process it, so I'll have to wait till they finish. I've got some stuff here now. If you want to install the Cisco Packet Tracer program on your Macintosh or your Windows, I've got a YouTube video here that shows how to do it. It's not my video. It's another Cisco guy's video. And then I've got, okay, if you want a brief introduction to Chapter 1 in 10 minutes, Dan's courses guy who teaches up in the Northwest has got a quick overview of that. I'll do it in about 5 minutes. And then he's also got a quick overview of Chapter 2, which I'm going to take more than 16 minutes today. I'm going to cover that more in depth. And then, of course, we have our Blackboard Collaborate Ultra link, which is this link here for this lecture right now. Okay, you guys hang loose 1 second here. I'm going to stop sharing this. Well, no one's got their camera turned on? You don't want to show me what you look like? Oh, that's okay. You can see what I look like there. I've got a photograph. Hang loose, and I'm going to check attendance here because some people have clocked in since I started talking. So hang loose 1 second. I'm going to mark these people as present. we get money from Austin. We send them pieces of paper with student attendance on us, and Austin sends us back $60 million a year. But we have to keep accurate attendance records. So that's what this is all about. Okay, he's here. Lloyd, he's here. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Missing somebody. Who am I missing here? Him. Oh, I found him. Okay. So it looks like we have 1, 2, 3, 4, 5, 6, 7 students at 10 moment. And then there's myself, and there's my ghostly alter ego, the one that says a preview user, which I use when I'm going to use that user to do packet tracer a little later on. Okay, let's see now. Let me go back to share my. Okay, I've covered the MyTCC. I've done the syllabus. Oh, now we need to look at the Cisco Network and Academy website. Good. Let me do that now. I'm gonna let's see. I need to share the window, and it's going to be this window. And I'll share it. Oh, it's the same one I did before. Okay. All right. Now, I have created a special student account for me to use to show you what it kind of looks like for you guys. So here is our course today. It's just starting today. I created it last week. It says that we're in week 2, but it's starting today. Not late. I am also teaching another advanced course, the capstone course on Tuesdays and Thursdays. And then this other course is the course I've already finished. They've actually completed this course, and they've all been graded on this already. So when you log onto the Cisco Network Academy, you're going to see something like this. Now, only about 5 of you guys or so have gone to the Cisco. I sent you guys all an email, and I sent a second email this morning, an invitation link from the Cisco Network and Academy, so that you can go to the Academy and change your name if you don't like the way it's spelled, create your own password, and you'll be able to get the online access to all this. So once you've done that, by the way, I used to be able to change people's names. I used to be able to reset students' passwords. Can't do that anymore. Cisco has changed their security. You can change your own password. If you forget your password, you can go to the Cisco website, netacad.net, and click on Forgot Password. You can reset your own password. We'll send you a link to your email where you'll be able to click and change that. You can change your own name. I can't change your name. If you change your name or I misspelled it or something, you can correct that yourself. I'm not able to do that myself. So you may only have this one link here. This is if you've never been on Cisco Academy before, never taken a course before, click on Launch Course. And let's see what the student sees when he logs onto Cisco Network. Oh dear, I haven't logged in. Let me log in here. Yeah, you got to see that username. That's not good security. Okay, so here we go. Before I click on Launch Course and show you the ebook, I'm going to show you these 2 tabs up here. And when you click on Grades, by the way, remember what I told you about paying no attention to the grading nonsense on Blackboard? In addition, pay no attention to the grading nonsense that's on Cisco Academy Canvas. The only grades that count will be the grades I key in the last 8 weeks. But you will be able to go in here and see, for example, I took the Chapter 2 exam, I took the Chapter 3 exam, and so forth. My formula, my suggestion for success in my Cisco courses is try to get a grade of 90 or above on the chapter exams. You get several attempts, and it is open book. So try to get 90 or above on the 10. I won't count Chapter 1. Chapter 2 through 11 will be 10 exams. And we also have another rule here that whatever grade you get on the final exam, if you miss a chapter exam or your final exam grade is higher than your lowest chapter exam, that'll replace that. That'll raise your grade slightly. So you can keep track of this. There are some other things on here like quizzes and stuff that don't count. When you click on the Assignments tab, this is where you actually go when you take the actual chapter exams, the course feedback form, the final grade, final test, and so forth. Come on now, change for me. Okay, so a final exam, you will take like the last week. The course feedback form, that's a student satisfaction survey. Cisco has a business rule that you must complete the course feedback form, which is an anonymous survey that I can't see who you are. So this is going to be your one chance to comment on my choice of bath soap. And you will be able to, they ask you, like, do you feel this course has prepared you to get a job in industry and stuff like that. They do require you take that course feedback form before you take the final exam. I guess they don't want you to be mad when you get a bad grade on the final exam and then you give a bad feedback. And we have our chapter exams. You'll be taking through 11, the practice skills assessment, and the skills assessment we will not be using in this course. Let's see if I can illustrate this. I'm going to click on the Chapter 2 exam. Let's see if it allows me to do it. Okay. Now you get this page and it says take assessment. And I'm going to go ahead and click on take assessment. Oh dear. It popped up a whole new screen that you probably can't see here. Let me see if I can go back into, go back to here. Let me go back to stop sharing this. Let me go back to share an application window, and begin assessment. Maybe this is it. Maybe I can share it like this. Okay, there we go. Good. So you go to this screen to take a test, and you click continue, and it tells you how many questions there are. And you click begin assessment, and then you see some questions have a circle on them. That means there's only one possible response. You can only click one. If you click the other one, it'll take the first one out. And you can go to another question. There's some other questions that may have, let me see if I can skip to one here. It has multiple responses. Okay, here's one that has, says, I always tell you, it has, instead of circles, it has squares. Excuse me. And they'll always tell you how many there are. So in this case, it says choose 2. So you can choose, I'm just going to click 2 at random here. You can click as many as you want. But if you choose more than 2, you won't get any of the question right. If you choose, let's say you chose 2 and one of them was right and one of them was wrong, you'll get 50% credit for the test. Okay, so let me see. I'm going to stop sharing that. So that's it. You've taken an online test before. That's how that works. Okay, let's see now. So I've covered the Cisco network. Oh, I need to show you on the Cisco Networking Academy how to see the ebook now. Let's see. So I'm going to go back to sharing. I need to share. So this. No, I need to put this away. Hold on. Wasn't that? Okay, I need to share this. Let's see. Stop sharing this. Share this. Share this. Here we go. Okay. Let's go back to home. And by the way, you can click home. If you click My NetAcad on the left-hand portion, that's going to take you right back to the list of courses you've taken on the Academy. So again, I'm going to click Launch Course. Now, we looked at grades, we looked at assignments. Now let's look at how to get the online ebook. This is the free ebook you get forever. There are print versions of this available for $35 or $40 that you can buy from the booksellers. But we don't carry them in our South Campus bookstore. So I'm going to click on Launch Course. Let's see, does it host you guys? Okay, this is good. Just to click on any of these pretty pictures here. And let's see, here's chapter 1. So it's typical ebook thing. On the left-hand side, there's a graphic of some sort. In the right-hand portion of the screen, there'll be some text. And there's an index feature that allows you to zoom in onto any page of any chapter. There's also a lab index that allows you to zoom into any lab if you want to look at it. I have posted all the labs that I will require of you on TCC Blackboard, so you don't have to print them here if you want to. There's a few videos, so you can go to the video and see those particular ones as well. Okay, stop sharing this. Okay, so I've covered my TCC Blackboard. We've looked at our class syllabus, see how the grading works. We've looked at the Cisco Academy website. So now it's time to look at our first Death by PowerPoint. And let's see, 1, 2, 3, 4, 5, 6, 7. Okay, nobody knew. And I'm going to share the file. All right. No, no. Share the file. Share this. Share now. And there we go. Okay, PowerPoint is starting now. Okay, just a few things from the chapter one, introductory one. I'm not going to test you on this particular one. So, clients and servers. Your computer is a client computer. Clients request services and servers fulfill requests. So when you log into the mail server, it sends you your mail. When you go to work and you log into the file and print server at work, it gives you access to the accounts receivable or whatever you work on if you were an accountant. So these are all connected together through a device called an Ethernet switch in the center of the graphic. It connects all of the devices together. So at the South Campus building, you've got a bunch of student computers. These are client computers. You've got a bunch of the dean's computer and the faculty teachers' computers. These are client computers. And we have some server computers. We have servers in the closet. There's a bunch of servers downtown in our data center at Trinity River. So servers provide information to end device. Oh, we haven't, wait a minute, no fair. We haven't said yet what an end device is. So in this particular diagram, an end device is like a client or a server machine. It's something that initiates the flow of data or receives the data. So when you print something to the printer, your computer is an end device that sends a job to the printer. The printer is an end device that receives the flow of data. It prints what you were trying to print. It flowed through some sort of network device like an Ethernet switch. Ethernet switches and routers are intermediate devices. They connect things together and they determine the best path. So on your desktop PC, you're running probably the Windows operating system. Maybe you're running the Macintosh operating system. Maybe you're way ahead and you're running the Linux operating system. So all these different devices are running operating systems. Your PC is running the Windows operating system. In a small business, where there's not, if it's a small business with less than maybe 10 or 12 people, they probably don't have a dedicated file servers, Microsoft server. They probably don't have dedicated system administrator to do stuff. This is the type of business you walk into it and everybody's password is on a yellow sticky note on the coffee maker in the break room. There's no security. So in these types of smaller operations, maybe someone's got a laser printer attached to their computer that's running plain old Windows, and they've right-clicked on the printer and they've shared it, and they decide what the password is. And someone else who wants to print a printer, the company's too cheap to buy laser printers for everybody. You'll just send your job through your network connection to the other PC who's got the line printer, and he'll print the job for you. So it's possible for your Windows computer, which is normally a client computer, to be a little bit of a server. It can be a client and the server at the same time. This actually slows down that graphic in the center desktop PC that is called print sharing. It's just a plain old Windows client computer, and we're burdening him with some extra duty of having to send print jobs to the printer and send it back and forth. So these are peer-to-peer networks. Easy to set up, lower cost. We didn't have to buy a server. We didn't have to hire a system administrator. Pretty easy to set up. But the disadvantage is there's no centralized administration. There's no centralized server or person that runs the server to have passwords. It's not as secure. It's not scalable and has poor performance. Now, scalable, what does that mean? Well, peer-to-peer works okay for about 10 to 12 people in a company. If it gets much bigger than that, it's too confusing. It's unworkable. If it's any bigger than 10 or 12 people, you're going to have dedicated file servers. You're going to have a dedicated system administrator or more than one, depending on how big the company is, to set people's passwords and do that. And we're going to have higher security. So here are the three different types of components on a network: devices, media, and services. The devices in the left-hand portion of that yellowish portion of that diagram, we have devices like desktop PCs, servers, Cisco IP telephones, Ethernet switch to connect everything together with. Those are all devices. In the middle of the diagram, we have some little round things. Those are called routers. Think of your home router. Routers connect networks together. Your home router connects your home network to your internet service provider, which is probably a cable company, maybe the phone company. And then at another office location, we'll have more servers, more Ethernet switches. These are all devices. These are actually pieces of physical hardware that you buy, and you put some type of operating system on them. The media that connects them together is the wires, probably twisted pair, category 5 Ethernet cables. Could be fiber optic, could be Wi-Fi, could be microwave. And then all these devices are running operating system software on them. So let's see, end devices. An end device originates data or receives data. So when I sent that job to the printer, I originated the print job, and it eventually ended up at the printer, and the printer printed it. So data originates with an end device, goes to the network, and arrives at another end device. The intermediate systems, like the routers and the switches, they choose the path. Just like when you make a telephone call, the telephone company switches choose the best path and make the guy's phone ring you're trying to call. An intermediary device is a device that makes path determination decisions. Examples would be your home router, a local area network Ethernet switch, a router that connects different networks together, a firewall device which has security code in it that prevents bad stuff from coming into the company network. So their job is to regenerate and retransmit data signals. Electricity flowing through an Ethernet cable that eventually starts to peter out. It's got to be strengthened up and regenerated before it goes over the next wire. These intermediate devices also, I call it routing by rumor. They chat with their neighbors and they learn what's the best path to everywhere else in the whole universe. So that no matter what website you want to go to, you'll be able to get a connection to it. Well, maybe not Twitter going to a news story that they don't like. That's okay. This is not a political class. I won't go into that. They also have the ability to notify other devices if they have an error or communication failure. You might get a pop-up on your screen, the network's down, the internet's down. Network media is all the stuff that plugs all this things together. Typically, copper cables with the RJ45 Ethernet plugs on the end of them. Could be fiber optic cables. Copper cables only go about the length of a football field, maybe 328 feet. Well, here on the South Campus, it's more than 328 feet to the library. We can't run twisted pair copper to the library. The signals would peter out. So instead, we use fiber optic cable. You can run fiber optic cable for miles, and the signal doesn't degrade enough. We can also use Wi-Fi or wireless radio frequency transmissions. So, types of networks. A local area network, that's what you have at your house. That's what we have here on campus. A local area network is a small geographically limited area that's owned by you at your house. Maybe it's owned by a division of a company. At a small or medium-sized or large business, it would be owned by that business. The characteristics of local area networks: it's 24-hour availability. It's not remember the old dial-up modems, the screeching cats noise from the 90s. You dial up the phone and you get the connection to America Online or something. And while you're using the phone for that, you couldn't use the phone for voice. So you had to hang up your connection before someone else could pick up the telephone using an analog screeching cats modem and make a connection. But local area networks today tend to be 24-hour full-time high-speed connectivity. Limited geographic distance, though, only 328 feet for that copper cable. So to connect all these branches together at Tarrant County College, we've got the South Campus, we've got some other campuses. How do we connect them together? Well, we can't just run a copper cable from the Southeast Campus to the South Campus. It's like 17 miles. We don't have the right to go and dig up the street and put our own cables in there. And copper cable wouldn't work because you can't send signals over copper cable that long. They peter out. We need fiber optic cable to do that. So we need to go to somebody like, what we do is we go to the telephone company. We go to Southwestern Bell, AT&T, and we lease a fiber optic circuit between our campuses. So a wide area network circuit connects the local area networks at each individual campus together. Some other types of networks he lists here. A metropolitan area network is a technology available in most thickly settled areas like the Dallas-Fort Worth area. This is a technology that allows you to connect your campuses together and in a more simplified fashion using Ethernet connections instead of having to use more complicated serial ports on routers. Wireless LAN, you probably got Wi-Fi on your home network, so that way you can plug it in with an Ethernet physical cable, or you can use the radio transmission features of Wi-Fi and you can connect to it within a certain distance. It won't go over a certain distance. A storage area network is a special, and its dyslexic cousin, network attached storage, SAN and NAS. These are what big data centers use to connect their disk drives with huge capacities together, so that all the computers, all the servers can share all these disk drives. That's beyond the scope of CC. Okay, so local area network characteristics: limited geographic area, one campus, one home, one school, administered by our IT department or home administered by you. High-speed bandwidth to end devices and intermediary devices within the network. Your home router is really a combination of a router and a switch and a firewall, all built into one box for $20 or whatever you paid for it price. So wide area networks connect these local area networks together. Two offices, one in Dallas, one in Fort Worth. They each have their own intermediate devices, routers and switches. They have their own end devices like PCs and phones. They have to rent capability from the phone company. They have that red jagged lightning bolt. It's 30 miles between Dallas and Fort Worth. They have to lease that line from the phone company. You have to lease from the cable company or the phone company your connection to the internet with your $50 a month or whatever you pay for that. So the internet is a bunch of LANs and a bunch of WANs all connected together, the public internet. All the internet locations are connected to each other, and so no matter where you're located, at work, at school, at home, you should be able to go to any location on the internet. And these use combinations of copper cables, fiber optic cables, Wi-Fi transmissions. The whole idea of the internet was it wasn't controlled by any individual government or group, and there are some groups that were developed to help make sure that everybody uses the same standards. Just like 150 years ago, governments got together and decided on what the standards would be for telephone communication. So if you want to call from here to France, they've agreed on how that would be transmitted, and most importantly, who gets sent the bill for that long distance call. Okay, a intranet is within the company. Tarrant County College has a faculty and staff intranet. We can see things like staff and human resources. How many days of vacation do I have left? Oh, that's right, teachers don't get vacation, just administrators. We're not allowed to call in sick, we're only allowed to call in dead. We got to come and meet the students. Extranet would be a company have a way of connecting to their suppliers, their customers, their collaborators. So for example, an auto manufacturing company might have a way of communicating with its auto dealers. And then the public internet of the whole world, the world plus dog, anybody can get to that stuff. Okay, new concept, fault tolerance. Fault tolerance or redundancy is a principle that, okay, these are devices, mechanical and electronic devices, they're gonna fail. We don't know when they're gonna fail. To expect them to operate forever without failing is irrational. We have to allow for the fact that eventually they may fail, and we have to have a way of working around that. For example, you guys that have taken the A+ class, RAID drive arrays. A RAID drive array, you can have 3 or 5 or more disk drives connected together, and the data is striped across all these drives, and if any one drive physically fails, your company operations don't stop. Everything is stored on the backup on the other drives, and you can keep working properly. And with network devices, we have this red thing over one of the routers. If that router fails, there's an alternate backup path. The red link is down. There's another alternate redundant path going to the green connection, and the employees can still talk to their customers and maintain sales and things of that nature. So we can get multiple paths and use multiple devices. This is called fault tolerance. The idea is, the principle is, any one device or wire can fail, and we can still do stuff. Maybe not quite as fast as we were doing beforehand, but at least we can still get our jobs done. Scalability is the feature that we should be able to expand our network without having to tear our whole system out and start all over again. So when we built the new air conditioning building at South Campus a couple of years ago, they didn't have to tear out all the existing infrastructure just to add another card slot to a machine. We simply added new devices together. So scalability, we can add Cisco devices or other devices to the network without having making completely obsolete all our old devices. Okay, quality of service. This concept is some stuff, if we delay it slightly, no one cares, but other stuff, if it's delayed, it causes a big problem. Let's look at telephone calls. You're used to telephones being, there's very low quality. They're less than AM quality. They're squawk box quality. But you're used to telephones being a high enough quality that you can understand the caller, you can recognize who he is. So the IP telephones, like the district uses, translate your telephone voice, analog voice into digital packets and send it to the network. Doesn't need a whole bunch of packets, doesn't need a whole bunch of bandwidth. But it needs to be just enough to where it's delivered and you can understand it. Or have you ever watched a YouTube video and it buffers? There's more bandwidth is required, and quality of service hasn't been configured properly. So we've configured our Cisco devices at the campuses to make sure that that telephone call, which needs very little actual bandwidth, put them to the head of the line. The other users that are downloading a web page, if they're delayed 1/10 of an extra second, they don't care. They'll probably even never notice. So in a later course, we'll talk about how we configure quality of service to make sure that the telephone calls and the video, audio and video stuff, we'll put it to the head of the line. Okay, security. When you come to the Tarrant County campus, or even when you logged into Web Advisor to sign up for this class, so you log into MyTCD Blackboard, you have to know your name and your password. So this makes sure that someone else doesn't sign up for your course. Nobody else can see your transcript. We've got rigid rules we have to comply with, like Family Privacy Act. When you come to campus, you put in your MyTC or Web Advisor name and password, and you'll log it to the lab computer. You can use that. So 3 things about security: confidentiality. You can only see your grades. Nobody else can see your grades. That's confidentiality. Integrity. No, we're not going to allow people to hack into you and change your grades to all A's, and you're not going to be able to issue yourself $1,000 tuition refund checks that are bogus. No, that's integrity. Our security is going to prevent that stuff. And availability, you should be able to get to your data whenever you need to. Occasionally, we have to take the systems down for maintenance. Occasionally, you'll see an announcement when you log in. Oh, Saturday evening from midnight to Sunday morning at 6 a.m., we may have the system down for some periodic maintenance. Okay, now I'm going to 1, 2, 3, 4, 5, 6, 7. Nobody knew. I'm going to stop sharing this. Let's see, stop sharing this. Make sure this is up. And I'm going to share the other PowerPoint presentation. Where did it go? Application window. Okay, did I make it go? Here it is. Why is it not showing up? English one. Oh, is this it? Oh, okay, here we go. Waiting for it to show up on your screen here. Uh-oh, I'm seeing blackness here. What the heck's going on? Okay, I'll try it again. Stop sharing. Share application. Share a window. Share a PowerPoint slideshow, and share it again. Oh, there we go. Oh, thank you, baby Jesus is working. Okay, good. There we go. Okay, so I'm going to talk about Chapter 2, which is something called the Cisco iOS. This is not your phone iOS. Cisco iOS was first. Apple stole the initials. Remember, good artists copy, great artists steal. We're going to look at the Cisco iOS as the operating system that's used in the network devices, the Cisco routers and the switches. We're going to see how we use that device and configure it. We're going to look at how you type in these commands. Every device on the network has to have a name. Your computer has a name. When you go into the system control panel of Windows, you'll see the name of your Windows computer. We need host names on network devices as well. We're going to see how we use the Cisco commands to limit access to device configurations. For example, put a password on it. We're going to use the Cisco commands to save the configuration. When you do a Microsoft Word document, you have to save it every now and then. We're going to do the same thing. We're going to show how devices communicate across network media. And then we're going to go to a host device like a desktop PC, a Windows PC, and configure his host address and verify connectivity between two end devices, typically using something like the ping command. 1, 2, 3, 4, 5, 6, 7. Just checking for additional attendance. Okay, all networking equipment depends upon operating systems. Your PC has got the Windows operating system. Laptops, smartphones have usually got the iOS system or the Android system. Switches and routers, they have the iOS operating system if they're made by Cisco. Now, Cisco has only got about 75% of the market. There are other people that have network devices. Many of them sort of copy the iOS system and make the command similar. Some of them have menu-based systems. At least 75% of what we learn in this course is not going to be Cisco specific, but you'll be able to operate and maintain anybody's equipment, not just Cisco equipment. Wireless access point, like your home router has got a wireless access point into it. On the campuses, we have wireless access points in various room ceilings. When you come to the lab on Wednesday, you'll see the wireless access point up on the wall there. Bring your tinfoil hat. You know, it's RF radiation. Firewalls are devices that protect or filter what information is allowed to come into the company network. So most companies have this, so they try to prevent hackers from coming in and messing with them. So the Cisco iOS is the network operating system on Cisco devices. Now, Cisco made a wise decision many years ago. The Cisco iOS is the same on all of their devices. So we're going to learn it on the switch first. And then when we go to the router, that's the same. Password, how do you set the password? The same. How do you set network addresses? The same. You only have to learn it once. And it works with any different Cisco device. Instead of a different, like, you know, what's the difference between setting your IP address on a Linux machine, on a Windows desktop PC, or the Windows operating system with a Mac? They're all different. So all operating systems have this construction. Here we have the guy in the purple shirt is using a desktop PC running Windows. He's got a graphical user interface. The Windows operating system is graphic, you know, point and click. There's also a CLI, command line interface, like the DOS command prompt. And this is the shell that the user gets. The shell, in turn, communicates with some code called the kernel. This kernel has extra super duper administrative abilities to connect with the hardware. You don't get to connect to the hardware yourself. For example, our student machines that we have in the lab, when you log into them, you don't have the ability to go and directly manipulate the hardware. You would hose it up. So you can't go in and mess with the IP addresses. We're going to use virtual machines, VMware virtual machines, or if you use the packet tracer, you get a simulated Windows system that you can use. So the kernel communicates between the hardware and the software. It manages hardware resources. Hardware is all the electronics part, all the physical part. So all operating systems, no matter whether they're Macintosh, OS X, Mac OS X, Linux operating system, Windows 8, Windows 10, whatever you're running on your desktop PC, they provide these functions that allow you to input data with your mouse or your keyboard, send data to a screen, send data to a printer, send it to another server. It manages all the processes and programs that are running. It manages the file system, like the Windows file system, so you have files and folders. It manages security, so you have to put in the correct password. The switch or router iOS does the same sort of a thing. It does the exact same function as the host operating system on a desktop PC or Windows or Linux or Unix server. It configures the interfaces. What's the network address supposed to be? It enables routing and switching functions because routers and switches are supposed to choose the best path. They're doing some functions that normal desktop PCs wouldn't do. So all network devices come with some sort of iOS operating system built into them. Switches, routers, firewalls. You can upgrade it if you want to add features. So for example, if you're an internet service provider, you might want to put in a feature called lawful intercept so that if some police agency comes with a subpoena, they can track your data. Now, on your desktop PC, the Windows operating system is stored in a hard disk drive, spinning rust. Maybe if a newer PC, it's a SSD drive, solid state drive. On Cisco devices, it's stored in flash memory. You go, wait a minute, flash memory is so slow, it's dreadfully slow. Oh no. So what Cisco devices do is they store the operating system in compressed form in the flash memory. And then when the device boots up, when the router switch turns on, he takes that code out of the flash memory, he puts it in RAM memory. RAM memory is 10,000 times faster than flash memory. It's about 1,000 times faster than hard drives. So it executes it from RAM memory. Windows does the same thing. When you boot up Windows, he takes the information from your slow spinning hard disk drive and he puts it in your RAM memory you have on your PC. Want to improve the performance of your desktop Windows machine? Put more RAM in it. So this is non-volatile. If you have a thumb drive as a flash drive, you put something into it and you unplug it, there's no power, it's still all there. You haven't lost it. I can change it. I can override it just like I can on the hard disk drive. And if I had enough space, I could store multiple versions of the iOS. Now, this is beyond CCNA. We're never going to do more than one operating system. But think of any of you guys that are A+ guys, did you install Linux on your Windows machine? And now you can dual boot into Windows or Linux. If you have enough room on your hard drive, you can do that. So when the switch or router turns on, he takes the iOS code from flash and he copies it into RAM memory. Now, RAM memory, when the power is turned off, is lost forever. You have to turn it on again and reload it. So the amount of flash memory and RAM memory determines what iOS we can use. That old desktop PC that you had from 15 years ago that was running Windows 7, and you want to put Windows 10 on it now, oh, there's not enough RAM. Got to put more RAM in it. The disk drive's too small. Got to get a bigger disk drive. So with Cisco devices, if we have a really old Cisco device, we might need to put more RAM chips in it. We might need to put a bigger flash card in it before it can be upgraded. So what are the things that routers and switches do? They do security. We're going to learn how to put a password protection on them. They do the routing or switching function, depending on whether it's a router or switch. They do quality of service. Remember that? Oh, we need to take the Cisco telephone set and put them ahead of the line. The marketing managers are having their monthly video teleconference, and they're going to get really mad if there's any buffering. So we need to give them first shot. They do addressing. Packets have to be addressed, just like mail has to have zip codes, and telephones have to have area codes. So we're going to address them so that they can choose the best path for them. Manage the resources on the device. The device has a limited amount of CPU cycles, RAM, and storage. We need to manage all that stuff. And then all those interfaces on the device, they need to be configured so they'll connect. Just like your desktop PC has to be configured so it can communicate with your home router. Okay. So first of all, when you turn on the Cisco router device, let's compare this first of all with the desktop PC. I'm going to turn on my Windows desktop PC. What happens? You see some flashing numbers on the screen. After a minute or two, you have the Windows, blue screen, and you have all your icons you can click on. So when a desktop PC boots up, the ROM memory runs a power on self-test and checks for any terrible hardware problems. And then he loads the operating system. It will load the Windows operating system from the hard disk drive. And the hard disk drive will boot up, Windows will load up, he'll check your password, and then he'll check something called the Windows registry to make sure that your icon's in the right place and you can start doing stuff. Now let's compare this with Cisco devices. Cisco devices turn on, number one. A read-only memory is a special type of chip that's burned in at the factory and cannot be changed. It contains the code to bootstrap up and load the operating system, just like your desktop PC does. It does a power on self-test. Sometimes computers, you'll see them count the memory. Then the ROM memory will look for something to boot up. Most PCs, that's going to be the hard disk drive. Older PCs, they might try to boot from the A drive, or they might try to boot from the CD-ROM drive. Most PCs, you can go in and adjust that in the CMOS setup utility. Cisco device is going to try to load operating system, and almost all the time in small and medium-sized businesses, it's that flash card that has the iOS for that device located on it. So number three, the Cisco device is going to go look for the flash card that's plugged in. It's going to have one copy of the iOS on it. He's going to boot that up. It is possible to configure Cisco devices to go and load the operating system from a centralized server. Inside the Cisco device is something called the NVRAM, non-volatile RAM. It's a type of memory that stores the configuration for that device so that if the power is lost, you don't have to type in all the commands and make it go again. So here's the 3 ways that the router can start up. If there is no existing configuration on the device yet, like factory fresh, or in the labs, we're going to learn when we finish with the device, we erase the device so that no one else has to mess with our passwords. If there is no existing configuration, we'll get number 7. So put a prompt on the screen that says, please set me up. If there has been an existing configuration that you've saved, copy run start, you've saved the configuration, it'll be saved in the NVRAM. And if the router power dies in the middle of the night, it comes back up again, it'll start operating again in just a couple seconds. Just like your home router, if there's a power failure, it comes back up, you don't have to reconfigure it. It starts operating. It'll take a minute or 2, it'll start operating. It is possible to also configure it to go to a TFTP server and do that, load its configuration from that. So in the router itself, or in the switch, there's RAM memory, there's the non-volatile RAM, there's the flash memory, and there's read-only memory. And there's some plugs to plug things together, like the console port and the Ethernet ports to connect to things. So our running configuration is going to be in the RAM memory. If the power is turned off, it's lost. If I haven't saved it in the NVRAM startup, I'll have to reconfigure it. I forgot to say, it's like if you go into Microsoft Word and type a paragraph, and then you click the X in the upper right-hand corner of the screen, and you don't save it, you'll have to type it in again. Now, remember that Microsoft treats you like an idiot. What happens if you go into the, and you type the X and you have a Word document you have updated, you haven't saved it yet? What is Windows going to do? Pop up a screen that says, oh, you haven't saved it yet. Don't you want to save it now? You should really save it now, you know. Oh, that's going to be lost forever. iOS does the same thing. If you try to reload the machine and you haven't saved it yet, it'll put up a prompt offering you to let you save it, the last chance to save it. The flash memory is like a flash drive, thumb drive, very slow. Flash memory stores the iOS operating system in compressed form. Every time the machine turns on, he takes it out of there and he puts it into RAM memory, where the running configuration is very fast execution. A ROM memory is that bootstrap program, that power on subtest. And it has a limited stripped down version of the iOS that we can use for the 2 things we normally use that for are if our iOS file in the flash goes corrupt or gets accidentally erased, we can put a new one in there. Or if someone leaves the company and they changed all the passwords and no one knows what the passwords are, we can perform password recovery and reset the passwords without having to entirely erase the device. So the permanent configuration file stored that's used during boot up, that's NVRAM. If I make a configuration and save it, it'll be stored in NVRAM. The diagnostic software, that's the ROM disk that does the power on self-test. The partial backup copy of the iOS is also stored in the ROM chip. That's for disaster recovery. The iOS is permanently stored in the flash memory. It'll copy it into RAM, it'll copy it into RAM memory and execute it from RAM memory. If the machine is turned off, RAM is lost. I don't care what you saw on CSI Tulsa, where they spray Freon on the computer that's turned off. This RAM memory chips have to be refreshed 1,000 times a second. And if the computer is turned off more than 1,000th of a second, everything in RAM is lost. That's bogus nonsense when they go to a computer that's turned off and recover the data from it. You have to save it to the hard drive. Where are changes to the configuration immediately stored? Well, in the RAM memory, but you have to save it to NVRAM with copy run start first. Okay, so ROM memory is the power on self-test. He loads the bootstrap program. He loads the operating system from probably flash memory, although alternatively we could load it from a server. The NVRAM is after we configure the device with our personalized information for our company location, our passwords, our IP addresses. He'll save that. If the device is a brand new device and hasn't been used yet, or it's been erased in the lab, we erase it when we're done with it. You don't want any previous lab interfering with your lab. It'll prompt you to save it. So the startup configuration goes in the NVRAM, the running configuration goes in RAM, the bootstrap program, the power on self-test goes in ROM, the iOS is stored in flash memory and gets loaded in RAM disk, and the ROM memory also contains a set of a stripped down iOS just for disaster recovery. But whatever is in the running iOS right now, it might not have been saved yet. You've never typed copy run started. It hasn't been saved. When you're in a commercial environment, Cisco has an online website called Cisco Connection Online, and you can get new files and updates and things of that nature. Now, here's a secret Gonzo secret insider tip of the day. Cisco switches carry a secret lifetime warranty. This is like the secret lifetime warranty on emission control system in cars. Even if it's a 15-year-old car and there's a problem with the emission warranty, they'll repair it for free. Cisco Catalyst switches carry a secret lifetime warranty, and if there's any security vulnerability that comes out in the future, even if you don't maintain a security, a service contract with Cisco, they'll give you a free copy of the new code. Normally, people in business and industry contract with Cisco on an annual maintenance basis, and they pay an annual maintenance contract fee so that if there's any hardware or software problems with it, they can get it fixed real fast. Because we're losing revenue if our machines aren't working right. Okay, here's a real Cisco device. This is almost exactly like the routers we have in the lab at South Campus. So what is that thing outlined in orange? It's baby blue color coded. So before we can program the device, we need to, home routers are different. Home routers come sort of pre-configured. If you're a cable customer, you can use your device. You only have, if you don't mind free Wi-Fi passwords and anybody else can get this stuff, you're going to get a connection right away. The Cisco devices routers come with no configuration on them. They need to be configured first. The only way is to go into this blue port, either the RJ45 connection or USB connection, and configure the device. So we have to use the console port initially. Once we configure the device and it has network addresses, we can, log into it with Telnet or Secure Shell and configure it that way or check it out. The auxiliary port, which is the one right above the blue RJ45, is an alternative way to plug in, but it must be configured first. You can't use it first. So we're going to use the console port first. There's no networking services have been configured. This is a brand new router that has no configuration, or you've come to the lab and there's no configuration yet on the device. So we're going to plug in the console port first. In our laboratory, we have got communication software on all of the student machines where you can come through and you can configure 2 devices at the same time. So we need a special type of console cable. It's color-coded baby blue, a rollover cable. And you'll see at your workstation, you have 2 baby blue rollover cables that go from your workstation in the lab to a little patch panel that takes you back to the back of the room where the routers are. And that way I can type in commands, and we're going to see these commands in a little bit here, these actual commands you type in. Good practice says we should use passwords. So we're going to use this. We're going to use a standard password so that if someone leaves the lab and forgets to erase it, you'll know what the passwords are. You won't be locked out. We're going to use 2 passwords, Cisco and class. This is a Cisco class. So those are the password pairs that we use for this. In a real world environment, you would put the device in a secure locked network area, because otherwise I could get to the console port, and even if I don't know the password, I can perform password recovery. If I can get my hands up close and personal on your device, all your bases belong to us, I've got it. I can change it. So if I have it locked up, only authorized personnel that have the proper key can get in and work on it. So this is what it kind of looks like. Here's a Cisco switch. There's a wire, the baby blue wire has been plugged into the console port. It's called the rollover cable, and it's plugged into the back of the desktop PC. And the desktop PC is going to run a piece of software that we used to run to talk to modems back in the old Screeching Cats modem days, 20, 30 years ago. We're going to run that terminal emulation software on the PC. We use a program called TerraTurn. And we'll be able to connect to that device and configure it. So by default, when you turn it on, it's already going to be set to this 9600 baud. This is the number of characters per second or bits per second. And you're going to get communicating with that right away. You won't have to change that. Some other communication programs, like the old HyperTerminal, you had to reset this. So if it's an older device, an older communication program, you have to change this. We shouldn't have to do this with ours. We're going to use TerraTurn, this one right here. This is an open source program written by some guy in Japan. And it's a very good program for connecting to devices and configuring. There are others out there you may have heard of. PuTTY is probably the world's most famous communication program. Secure CRT is a free program. HyperTerminal was given away free with Windows. Mac OS X has their own terminal program. So what we're essentially doing is we're going to take our $1,000 computer and turn it into a dumb terminal. In the old days, we used an RS-232 dumb terminal. We plug it in. So we're going to Do this to our PC so we can connect that device and start to configure it. After I've configured the router or switch to be on the network and have network addressing, I can ping it, I can telnet to it, I can remotely access the command line interface over the network instead of having to run down to where the device is located. It may be across the street and it's raining. It may be 1,000 miles away. And I'm responsible for the whole company nationwide network. I can still access it and manage it, test it. So this requires active networking services on that device that have been configured. Secure shell is better. Telnet has a problem in that everything that Telnet sends over the wire, including the name and the password, is unencrypted. And using a program we'll talk about later called Wireshark, which is a network sniffer, you can see your name and password in plain text. So secure shell encrypts the data. That way no one can see your name and password just because they're, climbed the phone pole in the back alley and clip their alligator clips to the wire, and now they're going to learn everybody's password. They're not going to be able to do this. So it's similar to Telnet. It works the same. You're going to get access to the device. You'll put in your password. That's much more secure. We'll see how to do that. Use stronger passwords. Everything, not just your name and password, but all data is encrypted. So unless you're on your PC or you're on the device itself, it's encrypted. You won't be able to see it. Auxiliary port is used. It used to be used. We'd plug in a modem, a dial-up modem to it. And if we lost our fast T1 connection to the remote office, we would dial in with our auxiliary port, try to fix it, instead of having to drive 200 miles to the remote location. Called out-of-band connection. Typically uses a telephone line with a dial-up modem. Beyond the scope of CCNA, we're not going to use it. But otherwise, it operates just like a console port. Okay, so the command prompt on a desktop PC, you go to the C prompt, and you can type ping and try to ping another workstation. Ping is a network utility that tests to see if there's a pathway. It's kind of like sonar, okay? I'm going to ping the submarine and I'm going to shoot him with my torpedo. I'm going to ping the other device with a special small packet and make sure he's alive and present on the network. A secure shell, SSH, is a program that allows me to connect to the other device and encrypt all the data so that it's safe. So when can I use a network connection to connect to the router? There has to be a network between them. It's been pre-configured and operating. So if I can ping it first, that proves I have a good network connection. Then I could run the secure shell program and log into it. So I would go and use the configure device. This shows in the upper left-hand corner the network control panel for Windows, and a particular IP address and subnet mask has been keyed in, and we're able to communicate on the network properly. So I'm going to take an Ethernet cable and plug it between my PC and my home router, or maybe between my PC and the switch that's in the wiring closet in a commercial business environment, called an Ethernet straight-through cable. And what he says, when should you not use a network connection to configure the router? Well, what if you telnet into device and you change the network address? You just lopped your, you just shot yourself in the foot and you're disconnected. And now you have to actually drive the 200 miles to the remote location and fix it. So we're going to use TerraTerm in the lab. I think they also have PuTTY on the machines if we want to use that. Some people prefer PuTTY. The guys that have been in the business for a few years usually prefer PuTTY. If you use the Packet Tracer program, the Packet Tracer has its own software emulation of all these functions that they can do. Okay, let's look at the Cisco IOS itself. It kind of is like the command prompt in DOS. You can click on Start, Accessories, Command Prompt, and get a sort of a black and white screen that's a command prompt. You type in characters, you press the Enter key. And the Cisco IOS is like this. It's a CLI. It's a command line interpreter. It's not a GUI like the GUI you have on the graphical user interface you have on your desktop on your home router. Use a point and click stuff to configure it. So let's look at these modes of operation. The user exec mode is the mode you get when you first log in. It's a very limited. It's a read-only mode. You can't do much stuff. You can do a little pinging, stuff like that. Normally, you're going to immediately type enable and promote yourself to the privileged exec mode, where you can actually do some stuff. When you're in the user exec mode, you have that little caret greater than sign that tells you you're at the user exec mode. Then when you promote yourself to the privileged exec mode, Before the passwords have been set, it will not ask you for a password. And when you type that, you'll go to the privileged exec mode, and it changes to the # prompt. And now we're going to type configure terminal to go into the configuration mode, where we can actually configure things on the router. Like, what is this host name going to be? What's the passwords are going to be? What is the routing commands going to be? What's the IP addresses of the different ports going to be? You can go into the global configuration mode to do this. So we might say interface and give the interface an IP address. We might type router and turn on the RIP routing protocol. Oh, that's right, RIP is out. We're going to use OSPF only. We'll get that in the last course. You won't have to worry about that this evening. So in the user exec mode, we have the user exec mode, and we'll type enable. By the way, the default host name of a switch is switch, and the default host name of router is router. We'll type enable and go to the privileged exec mode, and the prompt will change from the caret sign to the # sign. And then we have the global configuration mode, where we can go in and do some extra. We can do other commands like set the IP address, ping another device, and test it. So to be able to get from the user exec mode, normally when we configure those, we're going to configure the password as Cisco to be able to even get to the user exec mode. And then to get to the privileged exec mode, we're going to configure the password to be class. And if we want to go back from the privileged exec mode to the user exec mode, we type disable as the opposite of enable. It'll take us back. But the commands are pretty much the same, whether it's a switch or a router, anything that Cisco makes. So when you first connect to the switch, you're in the user exec mode. It's the greater than sign. We want to go to the privileged exec mode. We type the command enable. When we type configure terminal, we go to the global configuration mode. And then we want to give maybe we want to give a management address to the switch so that we can ping it and test it. Interface VLAN 1. The VLAN 1 is the management interface. And then we can give it an IP address if we want to. Configure terminal is the full command to get from the privileged exec mode to the global configuration mode. We're allowed to abbreviate these commands, just like you can in Linux and Windows. You're allowed to abbreviate, as long as it's enough of the word. It's unique to them. It's not duplicate with something else. I type config T instead of configure terminal. I want to configure VLAN 1 and go back to another mode. I can disable back to the user exec mode, go back to the privileged exec mode, go config T. This command, line VTY04, we want to set the passwords before people can come in through the telnet or secure shell function. So we can go back and forth between these various areas. Commonly, we're going to do something like this. We're going to log into the device. In this case, it's a switch. You can tell because the default host name is switch. Type enable, go to the privileged exec mode. No passwords have been set yet. Type configure terminal, and I'm in the configuration mode. And I'm going to give the switch a host name, like host name S1, host name S2. And I'm going to put in the password. Enable secret class is what we're going to use. That's the password you have to know to get from the user exec mode to the privileged exec mode. Now I want to put a password on the console. I'm going to type line console 0, password Cisco. I'm going to type line VTY04, password Cisco. And that way the people coming in through telnet or coming into the console port's protected. Banner message of the day. I want to put a warning message on it saying authorized users only, whatever your logger tells you to say. And I can go through an interface, like on the switch, I can go to the interface and put a management address on it. So logging synchronous is a command that makes it a little easier. Exec timeout 00, that means that when these Cisco annoyance messages pop up on the screen, it won't chop what you're typing up, and you won't be inadvertently logged out after 5 minutes. If you mistype a command, if you type no IP domain lookup, then you won't be stuck in the penalty box for 2 minutes waiting for it to come back. Interface descriptions are used so you can put like a circuit number or say this is the engineering lab. It shows up in other commands and makes it easier to see where you are. So let's take a look at this command structure. The ping command. I'm on the switch and I want to configure and see if I can ping a server or user's PC. So this is just like we type on a desktop PC in the DOS command prompt. Ping space the IP address we're trying to ping. So the prompt we get is switch. On the desktop PC, it would say C:\user. And we type the command ping, and then a space. And then we put our argument or keyword 192.168.10.5 and see if we got a connection or not. So it's a command followed by any keyword or argument. Different commands have different syntax. So argument is some value like ping what address? Well, 192.168.1.1. If I go into the description, I can say description, engineering lab. So in the manuals, they typically have boldface text indicates things you type in. And the non-boldface character is what you see on the screen. Italic text indicates something where you supply the value, like ping would be in boldface, and then the italics would be the particular IP address that you want to key into. So any character up to 80 characters. So in this case, we're configuring an interface port on the switch to say this is the description of the main headquarters office switch. Any arbitrary stuff. In the ping command, I could type ping and put in the IP address that I want to ping. The command is ping. The user-defined argument is this particular IP address, 10.10.10.5. Oh, no fair, we haven't talked about traceroute yet. Traceroute is kind of like ping on steroids. It allows you to troubleshoot where a connection has gone bad. And we would type traceroute and the IP address we're trying to get to. There's a built-in, super duper cool, context-sensitive built-in help command. If you forget a command, you can type the question mark and it'll show you what you could type next of all the possibilities. So if I was setting the clock on the device and I don't remember what order do I put in, the date, the hour, so forth, I could use the help command and it would show me exactly how to set the clock. All these devices, the Cisco routers and switches, have clocks with a battery backend, similar to your desktop PC, so it remembers what time it is. Excuse me. If you type a command and it's not finished, he'll give you the error message, incomplete command. If you type a command and you blow his mind, he'll put up a little thing telling you where he lost his mind. You type something he didn't understand. C. What can C be? What could be clock or clear? He tells you that's not enough. You can abbreviate, but you have to put in enough. So here he typed the clock set command, and he didn't complete it properly, and he put the little caret symbol that says, I understood everything up to that point, but after that, something went wrong here. I didn't understand it. So there are some of these are present in Windows and Linux as well. Tab completion is in Windows now. Control R redisplays a line. You can use the up arrow to repeat previous commands. Control C will break something and go and take you back so you can retype if you had a mistake. So to check to see what's going on in my system, there are show commands. I can type show commands and see what's going on with the system. Show run to see the running configuration, for example. So show version will tell me that stuff that flew off the screen when it first turned on. The Linux guys, when you boot up Linux, a bunch of stuff pops off the screen. You can't see it again. You have to type the message. Show version will show you all that stuff. How much memory, what version of the operating system is located. Show running configuration will show that RAM disk. What's the current running system configuration that's in the RAM memory? Show commands, what's in the tables and buffers. So what MAC addresses has this switch memorized? What's network addresses the VLAN been set to? The NVRAM was where we stored our backup configuration file. If I do show start, I can repeat that and see what it is. If you've never saved the device, it'll say startup configuration not found. You never backed it up yet. Copy, run, start is a command to save that. Show flash is kind of like the dir command in DOS. It'll show you all the files. As a matter of fact, dir works as an alias. It'll show you all the files present in the flash memory. Show interfaces, you can see, well, what interfaces does this device got? What are their IP addresses? So show version shows you all the stuff that shoots off the screen when you first go into the system. It shows you the version of in this case, it shows you that the system is the iOS version 15.0, and it shows you the stuff that normally flies off the top of the screen. Okay, there is navigating the iOS. Let's look at the host names. Why do we give things unique host names? So maybe you're doing a lab. The second lab that we do is going to be similar to what's shown on this page. It'll be 2 PCs and 2 switches. When you come to the lab and do it, it'll be 2 switches in the back of the room, and your desktop PC, PC-A and PC-B will be virtual machines running on your one physical router. If you do it in Packet Tracer, you just drag them to Packet Tracer and do it. So let's create a 2 PC network connected via the switch. We're going to set a name for the switch, S1 or S2. We're going to limit access. We're going to put passwords on it. We're going to configure a banner message of the day, and we're going to save it. So here our lady in the green jacket is configuring the switches on 3 floors. Which one is which? I'm so confused. Let's give them all a unique host name. Oh, switch floor 3, switch floor 2, switch floor 1. Now I know which one I'm working on, and I can configure it properly. Well, the dean's on the first floor. I got to give him extra privileges. I don't want to do it accidentally to some lab attendant on the second floor. So we're going to give them a unique name so we can know where they are with. We're going to do that first. So it has to start with a letter. Can't have spaces. Has to end with a letter or a number. So in this case, they started with a letter, they ended with a number. They can use dashes, they can't use spaces. Letters, digits, and dashes only. 64 characters maximum length. In most of our labs, it's going to be R1, R2, S1, S2, things of that nature. So to do this, the lady was logged into the first switch. She typed hostname SW floor 3. She set the host name of that switch on the 3rd floor to be that name so she could recognize it. By default, beforehand, it was the word switch, or the default host name. She goes to the switch on the 2nd floor and makes it switch floor 2. She goes to the switch on the 1st floor and she makes it switch floor 1. Now she knows which ones they are. Now the next thing we should do is put in passwords. The enable password is the one that limits our ability to get from the user exec mode, which we can't do anything, or read only, to the privileged exec mode where we can do anything we want to. So we need to use a password for that. In our class, it's always going to be class. So we're going to use the enable secret version of it, which encrypts it when you do the show run command, so people can't look over your shoulder and see what it is. It's has higher security. The console password is the one we're going to limit to that baby blue rollover cable that plugs into the console port. Before you can even get to the user exec mode, you have to know that password. That's always going to be Cisco. So the first password is always going to be Cisco. Second password is always going to be class. We're also going to set the Cisco password for the VTY, virtual terminal. That's if you come in over Telnet or Secure Shell to connect to a device that's already configured. You can't connect to the device so it's already been configured. You have to go through the console ports first. We'll use Cisco or class all the time. So in this example, the user has gone to the 1st floor switch, gone to the configuration mode, and typed enable secret class. And then she's typed disable to get out of the privileged exec mode and gone back to the user exec mode. If I waggle here, does it show up on the screen? And then when she typed enable, now it put the prompt up on the screen for password. Now this shows the word class in red. When you type it on a real device, it doesn't show on the screen. So no one looking over your shoulder can see it. It shows nothing. So you have to be careful and type it accurately. So enable secret is better than the older enable password. That's what we recommend now. Now let's set the user exec mode access. To the console, we're going to type line console 0, password Cisco, login. And to enable password to coming in through Telnet or Secure Shell, we're going to say line VTY 0 through 15 and set the same password as Cisco. 0 through 15 means there's only one physical console port. You only get one connection. Coming in through the configured network connections, you have up to 16 simultaneous connections at the same time. That's why it goes from 0 through 15. So we need to take this console port and put it in a locked network area, because if I can get into the console port, I can reset the password even if I don't know what it is now. There is no way anybody can come in through the network connection from across the campus or from Russia or something and reset the password through VTY. It's not possible to do that. We just want to support, if you know the password, to manage the device from a remote location. Okay, there's another command called service password encryption. Normally when I type enable secret class, it encrypts that on the screen and you can't see it. But the others are not encrypted, so we can type service password encryption and it will slightly encrypt them. It's not as powerful as enable secret, but at least if you have a printout or you got it on the screen, no one can look over your shoulder and see what the password show, see what the passwords are. Now, banner message of the day is a feature that before anybody even attempts to log in, you're going to see a warning. Warning, Will Robinson, this is a secure system. Do not attempt to log in unless you're authorized. We are tracking all communications. What are you going to put there? Whatever your company lawyer tells you to put there is what you're going to put there, according to your company's legal policy. And so you type banner message of the day and then put, in this case, the tic-tac-toe symbol, the pound sign. That's called the delimiter character. And then you type your warning message and then you type your delimiter character again. And everything between the tic-tac-toe sign It will be shown before the user even attempts to put in his password. So we used to be able to put wonderful greeting messages. Welcome to UTA C+ lab. Have a great day. But then the guys broke into the system and they hauled him into court. And the defendant lawyer said, "Your Honor," it said, "welcome." And the lawyer said, "Oh, you guys, you're free." Bam. So now we have to put nastygrams in there instead. You can't say welcome to the system. And that could be interpreted legally as welcome hackers. So now we have to put in warning, authorized users only, or you could be prosecuted to the full extent of the law, whatever the lawyer tells you to say. So don't use welcome, don't use invited. In the lab, you can put anything you want to. Okay, the show running configuration command shows the exact running configuration of the device at this moment in time. There's a default running configuration on the device that you have not yet configured. You will add passwords. You will add host names. You will add IP addresses when you configure devices. Once you've done some configuration, you want to, every now and then, you want to save it. You want to save it from the RAM memory. The running config is in RAM memory. You want to save it and put it in the NVRAM startup configuration file. Copy, run, start is a good abbreviation to do this. On switches, oh, he's getting ahead of himself here. There's a VLAN database file. If someone has created VLANs on that switch, you want to delete those and reboot the device. You want to erase the startup configuration file if it exists, and then reload it. This last block at the bottom is good practice for when you get a hold of a switch, and if it has any existing configuration on it that would mess up your lab, you want to do this first to make sure that it's been completely erased, and then you can reboot it. And there's the gotcha. Remember when I mentioned Microsoft Word? If you quit it and you haven't saved it yet, it prompts you to save it. If you've done a configuration on the device and you change the configuration and tell it to reload and you have not saved it recently, it'll prompt you to save it. Well, if you're finished with your lab, you're going to say no. No, you want to say yes, but you should say no. There is a feature in TerraTerm where you can copy the configuration from the device to a flash drive or something like that, where you can say, start the logging process, do the running configuration, and save it to that. You push your configuration back in later. Paste it in later. You can capture text. Now let's look at IP addresses on host machines. This is a Windows network control panel. Now most Windows machines you run into have the bottom, have the button that says obtain the IP address automatically checked, because they're going to automatically get it from a server. But in our labs that we do, we're going to put the IP addresses in by hand. We're going to click the second button that says use the following IP address. And we're going to key that IP address in. So 192.168. I'm going to click all this stuff in. I'll tell you what to do in the lab. You don't just make up something. When I worked at Harcourt in the 90s, we had mostly Macintoshes. Let me tell you something about Macintosh users. They already know everything there is to know about computers. They'd make up numbers and put them in there. And of course, they'd mess themselves up and everybody else on the network. So every end device must be configured with appropriate non-duplicate IP address, just like every cell phone has to have a non-duplicate cell phone number. Just like everybody has to have a unique zip code and street address for your mail to get to you. It's called a dotted decimal number. 192.168.1.1 is a common address we use. So it uses 4 decimal numbers. These actually represent binary bits, but we use decimal numbers because people are more comfortable with decimal than with binary. You stare at binary, you get a headache. So with the IP address, we also need something called the subnet mask. I don't like the word subnet mask. It sounds like it's hiding something from you. This is not Phantom of the Opera. I think it should be called the network yardstick or the network ruler. The subnet mask tells the computer how big its network is. And it can use that to determine when it sends something to another address, is he on my network or is he on some other network? So this is going to be assigned to both physical ports and virtual interfaces. So we're going to use virtual interfaces on the switch. We're going to use virtual PC on our desktop PCs. And we'll get those more in detail later on. I call them interfaces, I call them ports, I call them interface ports. They both mean the same thing. So on the routers and the switches, there are physical plugs you plug in RJ45 connectors into to wire up a lab. Now, due to the virus theater business, you guys won't be wiring anything up in the lab. I'm going to wire it for you because we don't have to worry about germs from the 3rd, 4th semester getting on the germs for you guys. I'll have all the labs wired up for you. You get to touch your machines all you want to. And then I think after every class they come in and spray Clorox on the room and disinfect it, something like that. So a router has got fast Ethernet ports. Our routers are newer, they have gigabit Ethernet ports. There's a console port, which we'll use, auxiliary port we won't use. There's a power switch and a power cord connection. Now look at that switch at the bottom. That's an Ethernet switch. It's very similar to the ones we use in the lab. It has 24 fast Ethernet ports and 2 gig ports. There is no power switch. Switches don't have switches. You have to take the power cord out or plug it into an outlet strip and turn the IR strip on and off. Why don't they have switches on them? Because idiot technicians would go in the wiring closet and turn them off. So we do not allow switches to have switches. So some interfaces can be configured with an IP address. We're going to configure your computer to have a specific IP address so it can communicate on the network. We're going to configure the router's Ethernet ports so that he can be your friendly neighborhood router and relay your messages to the other networks. Switches don't have to have an IP address assigned to them. As a matter of fact, switches will operate with no configuration whatsoever. But typically, we want to give them a management address. So we're going to do that VLAN address assignment and give an address to it. So on a switch, maybe we'll want to give it a management address. Now, by tradition, the router gets the first address. Your home router, let me see if I can guess the IP address of your home router. Let me see now. I'm going to use some telekinesis here, some reading of minds, and I'm getting 192.168.1.1. Oh, most home routers, that's not, I don't have ESP. Most home routers happen to be 192.168.1.1. Typically, the router gets the .1 address and the switch gets the .2 address. So in this case, the switch has been configured with the .2 address because the .1 address was saved for the router in that particular small business. That will allow me to communicate using secure shell or telnet or ping it to make sure the switch is operating on the network. Optional, not required. We're going to be using in our lab, though, to illustrate how you can remotely manage a switch from a desktop PC. They don't need the IP address. They'll forward all the Ethernet frames just fine. We're only adding it as a management feature. So a unique IP address together with a subnet mask uniquely identifies an end device on the internet network, just like the NAM and the telephone number on your cell phone uniquely identifies it on their network. So the subnet mask, I don't like the word mask, I think it should be called the network yardstick or the network ruler. How large is the network it's on? So we're going to go into the switch to interface VLAN 1 and give him this command in black here. IP address 192.168.10.2 space 255.255.255.0. Press the enter key. That configures the IP address on that switch. And then we're going to use the no shutdown command to turn on the interface. Excuse me. Shutdown turns it off. No shutdown turns it back on again. We can't use enable. That command was already stolen for something else. So we still need to have physical ports configured and VT lines enabled if we want what we just did here in black, if we want to remotely manage the switch. Now, on end devices, we're going to go into the network control panel and we're going to choose on our Microsoft Windows machine, we're going to type in a particular IP address. Typically, your PCA and PCB are going to be 192.168.1.10 or 1.11 or 10.10 and 10.11, and we'll put in those addresses by hand. Now, remember what I mentioned earlier? Obtain the IP address automatically. By default, all computers, Mac, Linux, Windows, have this set automatically because normally we don't want to have to run around and configure thousands of our client, desktop, student PC machines. It's too much of a burden. I used to have to do this before DHCP came out. In the 90s, I had to do this by hand. Remember the Mac guys that know everything? So normally your home router does this function. Normally in a business, there's a business server that does this function. So when you boot up your desktop PC, you come to the class and boot up your lab machine, it will get an IP address automatically. The Windows 10 operating system will boot up automatically. We don't have to configure that. You can't configure that. I can't give you the privilege to do that. You'll hose the machine and then other classes can't use it. Windows, as a matter of fact, if you configure a Windows machine to be the same as another Windows machine, Windows will take his toys and he will go home. Actually, he says this. He has determined that another device has the same network address as him, and the way he did that is he's just trying to ping it. He says, well, you told me to be this IP address. I'm going to ping it to make sure I'm not the only guy with this address. If he finds someone else responding, he says, oh, bad karma. I've got the same address as somebody else. For safety reasons, I will not participate in the network. Okay, verifying connectivity. There's a special reserved address on all desktop computers, 127.0.0.1, called the loopback address, just to make sure that you've turned on the TCP IP code in the network control panel. If you haven't, this will fail. And that orange thing on the right, Internet Protocol, if that's unclicked, the ping won't work. So at least we have IP turned on. And then we can go into the IP and we can adjust the network addresses later. So on a device like a switch, we did this command previously. We went to the interface VLAN 1 and we gave an IP address, and then we did no shutdown command. I'm going to type show IP interface brief on the switch, and he shows us that the IP address is up and up. So the switch 1 got 10.2 and switch 2 got 10.3. No duplicate addresses. That's the venial. Is that a venial sin or a mortal sin? Let me see. My wife is Catholic. I'll have to ask her. That's bad sins in networking. You can't have duplicate IP addresses. So I could test end-to-end connectivity here from the PC. I could type the command ping 192.168.10.2, and the sonar-like pulse would come to the network wire to S1, and he would respond saying, that's me, yes. And he would send back a reply. Echo request, echo reply. We'll get detail more on it later on, a later chapter. I could type 10.11 and ping the other workstation. PC1, PC2 would talk to each other. That's a very helpful command in networking to prove we have base network connectivity, because employees and programmers always say it's a network, and when you can say, well, no, it's not the network, it pings just fine. They always try to blame others for that. Okay, now let's see. I've got enough time here. I want to bring up the packet tracer program, and let's see. I'm gonna have to give them a responsibility to manage and give. Oops. No. Oh, here we go. I need to give make a presenter to the other PC. I'm now a presenter. And now I should be able to go over here and share. And what I'm going to first of all share is the picture of the lab that we're going to do next time. Oh, I have it minimized. Let's bring it up. It doesn't show up this time minimized. Okay, so this is the lab that we're going to do on Wednesday. Come in person, you get to do on the real, get your grimy on the real stuff. You can also do it with Packet Tracer if you want to do it that way. So I don't have real equipment here. I'm just going to use Packet Tracer to show this. So this is a simple configuration where we're going to connect the desktop PC to a switch, give them a management address, and try pinging to make sure it works properly. So now I'm going to go into Packet Tracer, and let's see if I stop sharing this. I go into this and share the application Packet Tracer. Can I minimize it? Oh, I must have minimized it. Okay, hang loose a second. Cancel this. Go to this. Share application. There, Packet Tracer, share. You should be able to see it in just a second here. Any second now, that sucker's going to come up. Okay, this is the free Packet Tracer program. If you go and log into the Cisco Networking Academy and click on the resources at the top, you'll see that you can download the Packet Tracer program. It's free. There's a version for Mac. There's a version for Windows. There's a version for Linux. Okay, and I put in my recorded presentation. I forgot to show you guys the recorded presentations. Or did I? In the recorded presentations, I have two things that one shows you how to install it on the Mac. I did show you that. So I lost my mind there, but I'm okay. I'm okay now. So in this particular lab, this is the drag and drop type program. So I'm going to go down and click on the network devices and click on the switch and bring a switch into the topology. And then I'm going to go down and click on the devices and drag a PC into the topology. Now in the real lab, we would actually have to go and connect a console cable. Here's the baby blue console cable. We would have to connect that between the serial port on the desktop PC and the console port switch. We also need to make an Ethernet connection between the PC's actual network card And we always use port 6 for the first one. Now, when you use packet tracer, you don't have to do the baby blue part, because if I just click on the switch, I'm going to get a prompt and I'll immediately be able to work on that switch without having to do that first. In the lab, when you come into the lab, we pre-wired all this stuff together, and you'll get this working properly. All you have to do is run the Terraterm program and connect to it. Okay, so I'm going to go into the switch and do some basic configuration on that. Maybe I should start with the PC. Let me click on the PC. And I'm going to go, let me expand this out a little bit. I'll go to the command prompt. Wait a minute. I need to go to the, sorry, I need to go to this first. On a real PC, you would go to the network control panel. I'm going to go to the configuration. And let's see, I forget what he said in the lab. I'm going to make it 192.168.1.10. And just like Windows did, put in the 255.255. That should take care of that. Now, if I go back and do this, and do this, so like Reagan said, trust but verify. The command we use on the PC is ipconfig. Oops, this is a simulation. This is not real Windows. So it tells us my IP address is 192.168.1.10. My subnet mask is the 255.255.2. Good, that's good. Okay, simple configuration on that. I can't ping the switch yet because the switch is not yet been configured. I didn't manage it. So let's go into the switch and do some real basic configuration on that. So original host name, the default host name is switch. I'm in the user exec mode because of that caret sign. Okay, so I'm going to type enable. I just typed EN, I used tab completion. And I'm going to go to the configuration mode, configure terminal. And I'm going to give them a host name S1. The prompt changes instantly to S1. Oh, good. Now let's give them an IP address. Okay, so let's see. I'm going to go to interface, VLAN 1. The prompt changes to config-if, configuring an interface. IP address 192.168.1.2. We're reserving 1 for the router, 255.255.2.0, and no shutdown. Now, I'm going to type one of the most important commands in CCNA that lets me know what's going on with this device. Show IP interface. You think it's easy typing these characters with a bunch of people looking at you? Get your own class. Okay, there we go. Most of it popped up off the screen here. We are plugged into port 6. It's up and up. Just my floating thing is not showing here. And that last line, VLAN 1, 192.168.1.2, it's up and up. Everything's on the up and up. We should be able to communicate with it. So I should be able, in theory, I should be able to ping my desktop PC. What was it? 192.168.1.10? And it worked. I'll do it again. It worked fine. The first one timed out, but the rest of them worked just fine. It timed out because of something called Address Resolution Protocol, ARP. We'll get that in a later chapter on theory and operation. Well, if I can ping the switch, the host PC from the switch, I should be able to ping in the opposite direction. So let's go back to our PC and go back to the command prompt. And I'll type ping 192.168.1.2, which is our switch. And it works. It works. Oh, great. So we have proved good connectivity. Now let's go back to our switch. Expand it a little bit. I'm expand it this way a little bit more. I'll wipe out the picture here because I want to not have so much line wrap. Okay, so show. Let's see what I want to do here. Oh yes, show the startup configuration. I haven't saved anything yet. Well, let's show the running configuration. So what have I done in this switch? Essentially, all I did was, do that again. I gave it a host name of S1. I didn't do passwords. I better do passwords, okay? It's on the network now, and anybody could hack into it because there's no passwords yet. So I'll go back to the configuration mode, and I'll say line console 0, password Cisco, and then the command login to allow logins. And I'm going to go to the configuration mode and do enable secret class. So let's see what happens here. I'm going to log off. Okay, now I have to put the password in. What was that first password? Oh, it was Cisco. It doesn't show on the screen. Okay, must have been accurate. Now I want to go to the privileged exec mode. What's that password? Class. Okay, so I knew it was Cisco. I knew it was class. Now when I do show run, see that enable hostname S1, and then it says enable secret, and there's a bunch of gobbledygook. That's the encrypted password. Can't see what it is. What about the other passwords? Look, password Cisco in plain text. Oh dear, that's kind of dangerous if I had a printout or it was on the screen. So that service password encryption command will hide that as well. Okay, so there's a little overview of using Packet Tracer. If you can make it into the lab and work on the real equipment. There's a Packet Tracer is about 95% good in the way it shows the what's going on with real devices. It's not like a macromedia flash simulation. It's not real equipment. It's not running the real iOS. It's running like snapshots of what it sort of acts like. The real equipment, you get it warts and all. You get everything working perfectly. So there's a few commands that don't work real well on the Packet Tracer. They'll work perfectly with the real equipment because it's real equipment. And that's the advantage of actually coming in and working actually in the real room with that stuff. And so you guys that want to do that, come in on Wednesdays at 9 a.m., we'll have the ability to do that real equipment. Now, as an extra bonus, even to you guys that can't come in, excuse me, I've done a run through here similar to what we'll be doing in this lab if you do it on Packet Tracer, if you're going to do it remotely. What I normally do every Wednesday is before you guys get to do the lab yourself, I will run through the lab on our real equipment in the room, and I will tape that whole presentation, that whole lab walkthrough, and I will put it in the recorded presentations link on Blackboard so you can see how it works with real equipment. There's a little bit of a difference slightly visually with how the real equipment differs from Packet Tracer. Of course, the real equipment is 100% real equipment. It won't suffer from that 5% fault that Packet Tracer has. Let's see now. I've covered Chapter 1. I've covered Chapter 2. I've shown Packet Tracer. I've given you guys the overview of Cisco Networking Academy. And so if you have not yet had a chance to go to the Cisco Academy site and respond to that, go to your MyTCC email, respond to that invitation. Look in your spam folder if you can't find it. I resent invitations out this morning to everyone that has not yet responded. If you have any problems, send me an email. I'll be glad to try to hook you up and get you fixed on with that. You have to be able to get on Networking Academy to see the electronic ebook and see the material in the course. And you have to get onto the Networking Academy to get that 50% of your grade for the 10 chapter exams. Chapter 2 through 11, Chapter 1 will not be required, and to take the final exam in the course feedback form. If you don't want to come to the real labs, then the other 50% of your grade will be from the labs that we do in the course. You can do them on Packet Tracer if you like, or if you don't want to, can't make one lab or whatever, you can use Packet Tracer to make it for that. I do drop the lowest lab grade, so you can safely skip one lab and it won't hurt your grade. Okay, I'm going to hang loose for about 1 second here, about 1 minute, if anybody has any chat questions or anything like that. But other than that, I think I've finished. And you guys that want to come in person on Wednesday, I'll be happy to meet you guys in SVUS 1125 on the South Campus, which is the building is on the it's on the closest to the public school stadium on the east side of campus. If you don't want to come to the real labs, you always have the option of using the Packet Tracer. Okay, hang loose 1 second here. I'm going to cease recording, turn off the recording.